Okay, now I will be starting today. Am I audible to you? Can you hear me?
Yes, I'm able to get you.
Okay, so now we will be starting. Today we will be moving further. We will be starting, I will be just revising measures of central tendency, that is your unit 30, which is the most important part of statistics. Now, here the concept of central tendency starts. For a proper appreciation of various statistical measures used in analyzing a frequency distribution, it is necessary to note that most of the statistical distributions have some common features. If we move from lowest value to the highest value of a variable, the number of items at each successive stage increases till we reach a maximum value. And then, as we proceed further, they decrease. The statistical data which follow this general pattern may differ from one variable to another in the following three ways. The first one is they may differ in the values of the variables around which most of the item clusters, that is the average. Second one, they may differ in the context to which items are dispersed, that is dispersion. And thirdly, they may differ in the extent of departure from some standard distribution, which is known as normal distribution. In that case, we find skewness and kurtosis. Now, let us discuss the first type of measure, which is called averages or measure of central tendency or measure of location. So first, we will start with definition of central tendency. According to Clark, he defined it as average is an attempt to find out one single figure to describe whole of the figures. Another definition for was given by Croton and Cowden. They defined it as an average value is a single value within the range of the data that is used to represent all the values of the series. Since an average is somewhere within the range of the data, it is sometimes called a measure of central value. An average of a given data is frequently referred to as measure of central tendency. What are the objectives of average or central tendency? The following are the main objectives. Number one, to supply one single value that describes the characteristics of the entire data. An average reduces the complex mass of data into a single representative value, which enables us to grasp the salient features of the data without getting lost in its details. Thousands or lakhs of values can be represented by a single value. Second one, it facilitates comparison. It is not easy to compare the two huge raw data, but the two different data sets could be easily compared by working out their averages. Comparison can be made either at a point of a time or over a period of time. Third one is to facilitate statistical inferences to draw inferences about the unknown measures or parameters of the population. We depend on values calculated from sample. This known as statistical inference. An average obtained from a sample is helpful in estimating the average of the population. Fourthly, it helps for decision making, or we can say that it helps in decision making process. The averages are computed to help the managers in decision making. The managers are often interested in knowing normal output of the plant, representing sales volume, overall productivity index, price index, etc. These all are the canonizations of an average. Now, what are the essentials of an ideal average? As suggested by the eminent statisticians Yule and Kendall, an average should possess the following characteristics. First, easy to understand and simple to compute. Secondly, rigidly defined. Thirdly, it should be based on all the items in the data. Fourth, not to be unduly affected by extreme items. Fifth one, capable of further algebraic treatment. Sixth one, sampling stability. But these are the observations which were made back by the eminent statisticians about what the average should have. Now, these characteristics should be in the value what we get, which represents the entire data. What is the different measures of central tendency? As number one, mathematical average. If we talk about mathematical average, it's straight away it is related to arithmetic mean, geometric mean, harmonic mean. Please mute yourself. Second one is averages of position. If we talk in terms of the position, that is median or the partition values, which are quartile, decile, and percentile. And the third one is mode. But these all three things comes under averages of position. Now we'll start with arithmetic mean. The word average we use every frequently in day-to-day expressions, such as average price, average income, average weight, etc. In these expressions, the word average is nothing but arithmetic mean. Generally, a layman call an average, but a statistician call it as arithmetic mean. The arithmetic mean is commonly known as mean. It is a measure of central tendency because the other figures of the data congregate around it. Arithmetic mean is obtained by dividing the sum of the values of all observations in the given data set by the numbers of observations in that. It is the most commonly used statistical average in the discipline such as commerce, management, economics, finance, production, etc. The arithmetic mean is also called as simple arithmetic mean. Now, how to compute or how the computation of arithmetic mean takes place. As you know, the collected data is classified by arranging into different classes or groups on the basis of their similarities and resemblance. Arithmetic mean can be computed from the unclassified or ungrouped data, which is known as raw data. as well as classified or group data, but the method of computations are different. Arithmetic mean is denoted by x bar. If we talk about ungrouped data, is the screen visible to you?
Yes, sir.
Okay. So I was talking about arithmetic mean for ungrouped data. As I told you, it is denoted by x bar. And in simple terms, arithmetic mean for ungrouped data is summation of all the observations divided by number of observations. So as you can see that x bar is equal to x1 plus x2 till xn divided by number of terms, which is n. That is for ungrouped data. Then please mute yourself when the values of the observation in the given data are too large or they are in fractions. This method may be followed. And this method is based on the fact that the algebraic sum of the deviations of a series of individual observations from their mean is always equal to 0. For to compute this arithmetic mean, there are different methods which are initially applied to the data given to us. First one is we have to assume any arbitrary mean. Normally, it is taken at the central data given to us, and it is denoted by A. Number two, we have to compute the deviation, and these deviations are denoted by D. D, which is equal to x minus A. Third one, we have to sum all the deviations, and which is denoted by summation of D. And then we have to evaluate the arithmetic mean. Now we see to the problem. This is basically a method where you can see that the frequency, which is in terms of sales, is a two-digit number, which is which has to be multiplied by the dealers. What we will be doing, we will be simply okay. So this data is given to us. We will be assuming some value of this after seeing the sales column, a number which may be at the middle of the series. This is we can say that it can be assumed as 25. So A becomes 25. Now going back to the table, you can see that there are dealers, that is the sales, and now we have to calculate the deviation. The deviation, that means this sales has to be subtracted by 25. So that means 23 minus 25 is minus 2. 8 minus 25 is minus 17. So similarly, we will be calculating for the whole column. 46 minus 25 is 21. Now we will be adding. What is this additions or summation is known as summation D. Summation D is equal to minus 24. Now we have arithmetic mean as 25. Assume arithmetic mean as 25. Your summation D is minus 24 and your N is 10. That is number of observations. Now we will be applying this relation x bar is equal to A plus summation D upon N. We have every value with us. A is 25, summation D is minus 24, and N is 10. After placing up the values, we get 25 minus 2.4, which comes out to be 22.6. That means the average sales per month for the 10 dealers is 22.6. This is a simple first method. Now we will be moving further when the data is group data. When the data is group data, it can be categorized as discrete variables and continuous variables. The frequency distribution prepared for discrete variable is called discrete distribution, and the frequency distribution prepared for continuous variable is known as continuous distribution. Method of computing arithmetic mean for these two types of distributions are different. When we will start with discrete series. In discrete series, what you can see that there is slight modification in our basic formula. That is, x bar is equal to f1 x1 plus f2 x2 till fn xn whole divided by summation of the frequency. That is, f1 plus f2 till fn. Mathematically, in the terms of formula, it can be written as x bar is equal to summation fx upon summation f. Now, the second method is where frequency increases. So what we will be doing? We will be finding out the deviation. Now here, this is also known as, the second method is also known as shortcut method. Here what happens? As I told you, when the frequency distribution is large, we normally prefer this method. Procedure is that what we did for x bar equal to a plus summation t upon n. Here, slight modification is there. First of all, we have to assume a mean. Then we have to calculate deviations. That deviation is equal to d is equal to x minus a. We have to obtain another column that is summation of fd. That means this deviation has to be multiplied by frequency and we have to add it up. And the second column we will be having frequency. So that means we have to calculate, we have to sum up that frequency, which will be summation f. Now, what is the modification in the formula? Modification in the formula is x bar is equal to a plus summation fd upon summation f, or x bar is equal to a plus summation fx upon n. Now, we see this is the data, and you should have pen and paper with you so that it will be easy for you to understand the concept, because this is mathematical component, so you have to write it with your own hands out, so that will be easier for you to understand later on. We have to calculate the
Alright,
arithmetic.
sir.
Now I will be calculating arithmetic mean by two methods. The question is given to us the marks and the number of the students. I will be transforming this data into a tabular form. In a vertical position. First of all, I will write marks, then number of students. Marks will be denoted by X, number of students will be denoted by F. Initially, this thing has to be done. Now, what I will do? You can see to it that frequency number is too large and your X is also large. We will be finding out the product of F and X. Refer to the last column. There, the product of fx is there. 10 into 8 is 80. 20 into 21 is 420. 30 into 23, 690. And similarly, we will be calculating till the last. That means 80 into 2 is 160. Now, what we will be doing? We will be summing it up. That means we will be finding summation effects. Going back to the formula, method 1. X bar is equal to summation fx upon n. Your summation fx is 3679, 3670, and your summation of n is 100. So that means we can say that after dividing it, we get 36.70. Or we can say that the arithmetic mean for this data is 36.70. Initially, I said that frequency is too big and your x, that is the marks, are also big. So I will be opting for another method, that is method 2, that is also known as shortcut method. Now here in that case, I have to assume a value. So normally, as I told you, it will be a value which will be presented to you in the problem, and it can be assumed as a central value of this class mark, this marks. So here you can see that 8 observations are there. So I can take the fourth one as an assumed mean for this particular problem. So here what will happen? Our A will be 40. Now we have to calculate deviation. Deviation. Madam, please mute your. Going back to the problem, here what has happened? We have assumed a value, which is known as assume mean. And here in this case, it is A is equal to 40. We have taken the central value. Now we have to calculate deviation. And this deviation is calculated as D is equal to X minus A. As A here is 40, so it will be X minus 40. So we will be subtracting the values 10 minus 40, which comes out to be minus 30. Be careful about the sign of these observations. Normally, learners make this error. We have to be, one has to be very careful. 20 minus 40 is minus 20. 30 minus 40 is minus 10. 40 minus 40 is 0. 50 minus 40 is 10. And similarly, for the last one, it is 80 minus 40, which is 40. Now we have to calculate F into D. F into D means we have to multiply 8 by minus 30, which comes out to be minus 240. 21 multiplied by minus 20, which comes out to be minus 420. 223 multiplied by minus 10, which comes out to be minus 230. And similarly, we will be doing it for the last 2 into 40 is 80. Now, we will be summing all these values. That means we will be summing minus 240, minus 420, minus 230, plus 150, plus 180, plus 150, plus 80. So normally, after doing the summation, we will be getting summation FDS minus 330. Now, going back to the formula, method 2, which is also known as shortcut method, x bar is equal to A plus summation FD upon N. Here A is 40, summation FD is minus 330, and your summation N or summation F is 100. So after calculating, we again get 36.70. That means we can see that finding mean by two different methods does not affect our answer. Both the cases we are getting 36.70. Now, the third step is, or the third method is basically, is also known as step deviation method. Again, everything has to be done in this mode only, but there will be some modification in step number 3. The formula of previous two methods can be used conveniently if the values of variable x and variable values of frequency f are small. If the values of f and x are large, computation of mean by using the above methods are quite tedious and time consuming. That means we have to find it another method. Here, first of all, we have to calculate the mid value of each class, and we have to select assume mean from the mid value. Second one, we have to calculate deviation. Deviation is m minus a in this case because we have calculated the mid value. Third one is find the common factor, that is I, and divide the above deviation d by I, which is denoted by d. Now we will multiply the reduced deviation d in step 3 with the corresponding frequency, which will become fd, and we have to submit. We have to do the summation of it. That means we have to add all these values. And step number 5 is the summation of all the frequencies or all the observations. That is summation f or n. Now, what is the formula? Formula here you can see that x bar is equal to summation fd upon summation f into I. You are aware of all these values. Now we will see how this particular formula is applied in a practical problem. This data is given to you, and we have to find the monthly sales in dollars for 135 organizations. We are given two things, that is monthly sales and number of the funds. So we will be converting this data in a simpler form, and we will be applying this above formula, which is x bar is equal to a plus summation fd upon summation f into I. Now the question arises how. Now see, these two columns were given to you. We have this monthly sales column was given to you, and the number of the firms was given to you, which is denoted by F. Now we have to calculate the mid values. Mid value is denoted by capital X. How this mid value is found out? 0 plus 150 divided by 2, which comes out to be 75. Now you can see, in spite of doing for the respective each row, we can see that the difference between the class intervals is 150. So mathematically, we will be adding 150 to 75, which comes out to be 225. Again, we will be adding 150, which comes out to be 375. And we will be adding this 150 to all. So our series will be 75, 225, 375, 525, 675, and 825. Here you can see that there are 6 observations. We can take the third one, or we can assume it A is equal to 375. Now we have to calculate the deviation. Now listen to me what I am telling you very carefully. It will be easier for you to calculate the value of D. First of all, how D is calculated, that is shown to you below D, x minus 375 divided by the difference, that is 150. Now, See to that table very carefully. You have assumed A is equal to 375. In front of that, simply put up 0. I'm talking about this 0. Above it, write minus 1, minus 2. You will get always minus 1, minus 2. And below 0, write it 1, 2, 3. I'm repeating what I told you. While calculating the value of D, mathematically D is x minus 375 upon 150. Putting up the values individually and calculating it will be a time consuming exercise. What I said, the class where you have assumed, straight away put 0 in front of that. And over it, write minus 1, minus 2. And below 0, write 1, 2, 3. Now, you have to multiply this f with this d. 12 into minus 2 is minus 24. 25 into 1 is 15. 10 into 2 is 20. And 5 into 3 is 15. Add all these values. You will get summation fd equal to 1. And you have to add all these frequencies. Summation f will be 135. What is our formula? X bar is equal to A plus summation FD into I upon summation F. Your A is 375, summation FD is 1, I is the difference, that is 150, and summation F is 135. When you will be putting all these values, you will be getting mean as $376.11. This is the method which we will be using frequently, and here in this particular method, multiplication, working, calculations are very less, and it is very simple to do. Now, what is weighted arithmetic mean? The simple arithmetic mean of the prices of such commodities which not predict a true picture of their living pattern. Different commodities are to be assigned weights, and a weighted arithmetic mean is to be worked out in such situation. In a factory where unit cost of manufacturing is to be worked out, a weighted average is more appropriate. Now the question arises how it is calculated. When we talk about weighted mean, so it is denoted by x bar w, which is equal to summation wx upon summation w, where W is the weighted mean weights and X is the observation, the class marks given to you. You have to simply multiply those and divide it by summation of the weights. Now, what are the uses of weighted arithmetic mean? We can arithmetic mean is mainly useful under the following conditions. When the given items are of unequal importance. When averaging percentage which have to be computed by taking different numbers of them in the denominations. When statistical measures such as mean of several groups are to be combined. To be more specific, weighted arithmetic mean is used in the following cases. When developing or construction of index number is there, computation of standardized birth rate and death rates, finding out an average output per machine when machines are of varying capacities, and determining the average weights of skilled workers of a factory. What are the properties of arithmetic mean? The summation of deviations of the arithmetic mean from the arithmetic mean is always zero. That means summation of x minus x bar is always equal to zero. The sum of the squares of deviation from the arithmetic mean is minimum. That is, it is always less than the sum of the squares of deviations of the items taken from any other value. That means we can say that summation of x minus x bar whole square is always minimum. It is not zero, it is always minimum. If the number of items and means are known, the total of the items can be obtained by multiplying the mean by the number of items. That is, x summation x is equal to n into x bar. If you recall the primary definition of mean, x bar is equal to summation x upon n. I'm talking about that thing only. If we add or delete the observation, which is equal to mean, the arithmetic mean remains unaffected. If each of the values of the variable x is increased or decreased by some constant c, the arithmetic mean also increases or decreases by c. Similarly, when the values of the variable x are multiplied by a constant, say k, the arithmetic mean is also multiplied by k. And if we have the arithmetic mean and number of items of two or more related groups, we can have a combined mean of these. What is that? X bar combined is equal to, we suppose we have two sets of observations. In that case, combined mean will be equal to n1 x1 bar plus n2 times x2 bar divided by n1 plus n2. Now, what are the merits? Since everything has advantage and disadvantage, similarly, arithmetic mean has limitations and merits. If we talk in terms of merits, it is easy to understand and simple to compute. It is widely used, summary, measure. It is rigidly defined. It acts as a single representative figure of the whole data set. It is based on all items of the data. It does not depend on its position in the series. And the fifth one is it leads itself to further mathematical treatment. And if we talk about the limitations, it is unduly affected by extreme values. Very small and very big values in the data unduly affect the value of the mean. Secondly, for the open-ended distribution, mean cannot be computed with accuracy. Mean is not useful for studying the quantitative phenomena. And for the reasonably norms, that is bell-shaped distribution, mean can act as a good measure of central tendency. And its application is in research work. Now we talk about geometric mean and harmonic mean. How to calculate geometric mean? In this situation, when we deal with quantities that changes over a period of time, we may be interested to know the average rate of change. In such cases, the simple arithmetic mean is not suitable, and we have to resort to the geometric mean. Now, how it is calculated? Geometric mean is, like other averages, computation procedure of geometric mean is different from group data and ungrouped data. If we talk about ungrouped data, geometric mean is equal to under root of product of all the values, and that under root is to the power of number of 1 upon number of terms. Mathematically, it is written as n under root summation of all the product of all the observations. And for the group data, it is nth root x1 power f1 into x2 power f2 till n, etc. Now we will see how this geometric mean is calculated. This is group data. We have X and F. For this, basically we have to apply a logarithmic method. The geometric mean is antilog of summation f log x upon n. This is the formula what we apply. Now we have to calculate the product of f and log x. First of all, we have to evaluate log x. Log x means you have to evaluate the value of log 5, which this value can be obtained from the log table. Log 5 is 0.6990, log 15 is 1.1761, log 25 is 1.3979, log 35 is 1.5441, and the log 45 is 1.6532. Now we have to multiply this log x by f. So 5 into 0.699, it comes out to 3.4950. And going down the table, when we will be multiplying 8 by 1.6532, we get 12.2256. The last column has to be summed up. That means summation f log x, which comes out to be 84.5243. And we have to calculate this summation of n also. Here in this problem it is 60. Going back to the formula, we have antilog of 84.5243 divided by 60, which comes out to be 1.4087. After calculating the antilog from the log table, we will get 25.63. That means the geometric mean for this data is 25.63 marks. Now, what to do with continuous series? The only change in the earlier formula of geometric mean is that the x is replaced by n. What we will be doing? That means your geometric mean will be antilog of summation f log n divided by n. The problem is in front of you. You have to calculate geometric mean. It is a continuous series and a group data. Formula is there, so what change has to be performed over here? Now see, class interval and frequency were given to us. Now we have calculated the mid value, which is denoted by n. 7.5 plus 10.5 divided by 2 will be 18 divided by 2, which is 9. Now you can see there is a difference of 3. We will be adding 3 to all values of midpoint. 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 3 is 18, 18 plus 3 is 21, and 21 plus 3 is 24 and 27. Now we have to calculate log m. Our m is 9. Log 9 is 0.9542. Log 12, 1.097. Log 15, log 18, log 21, log 24, and log 27. Log 27 is 1.4314. Now what we are supposed to calculate? We have to find out f log n. F log n, that means 5 into 5 into 0.9542, which comes out to be 4.7710. 9 into 1.0797, 9.7128. Similarly, 19 into 1.1761. This is 22.3459. And at the bottom, we have 1.4314 into 1, which comes out to be 1.4314. We have to add all this. And mathematically, it is written as summation of f log f, which comes out to be 81.9092. Go back to the formula. Your formula is geometric mean is equal to antilog of product summation of f log n log x divided by n. Here summation is 81.9092 divided by summation of frequency. It is here 68. We will be getting antilog 1.2025. From the table, we will be getting the value of antilog 1.2045, which is 16.02. That means the geometric mean is 16.02. Now, the uses and the limitation of geometric mean or the average is what we are discussing right now. For computing the averages of ratio and percentage, geometric mean is the most suitable average. As it has bias, it has towards lower value. It is particularly useful when a given phenomena has a limit for lower values but no such limit for the upper values. In the construction of index number, geometric mean is considered to be the best average. When large weights are desired to be assigned to small items and small weights are to be assigned to large, then it is a more suitable or stable average than arithmetic. Now, its limitation. Even if the single item of the given series is zero, the geometric mean will be zero because you are multiplying it. If any of the item is negative, geometric mean does not exist because you cannot calculate the value of under root -4. The computational procedure is difficult, especially when the items are very large because you have to calculate log and antilog. Its bias for lower values obstruct its use in the situation where disparities are to be highlighted, as the case of income distribution. Now, how to calculate harmonic mean? For we have three types of data. First one is ungrouped data. Second one is group data or the discrete series. And the third one is group data continuous series. What will we do? First of all, two activities have to be performed. We have to find out 1 upon x1 individually, then we have to sum up. Going back to the formula, it may be called as the reverse of a form of something reverse of arithmetic. Here, total number of frequency or the summation of number of terms is in the numerator, and in the denominator we have 1 upon x1, which we have already calculated. So we will be adding up all. Harmonic mean is reciprocal of arithmetic mean of reciprocals. If we have discrete series or the group data, it is equal to n upon summation f into 1 by x. And if we have group data, then we have to just do the reciprocal of group data. Now we will see how this harmonic mean is calculated. The data is given to you. See, Class interval and frequency were given to you. We have to first of all calculate mid value. Mid value in the first case will be 0 plus 10 divided by 2, which is 5. The difference is 10. So we will be adding 10 to all. 5, 15, 25, 35, 45, 55, and 60. Then we will be calculating 1 upon n. 1 upon n means 1 upon 5, which comes out to be zero point 0.2. 1 upon 15 is 0.067. 25, 1 upon 25 is 0.04. 1 upon 35 is 0.029. 1 upon 45, 0.022. 1 upon 55, 0.018. And 1 upon 65 is 0.015. We have to multiply this 1 by m into frequency. That means f into 1 by m, which is 5 into zero point 0.2, which comes out to be 1. Similarly, 8 into 0.67, which is 0.536. And at the bottom, we have 3 into 0.015, which is 0.045. So we will be adding all these values of this column, which comes out to be 2.591. Now going to the formula. Formula for arithmetic mean, the group data is n upon summation of f1 into 1 by n. So we have n is equal to 51, and the summation of f1 by m is 2.59. After evaluating or calculating or simplifying, we get 19.68. That means we can say that for this data, arithmetic mean is 19.68. What are the properties of harmonic mean? If each value of the narrates is replaced by harmonic mean, the total of reciprocals of the value of the narrate remains the same. Harmonic mean is the reciprocal of arithmetic mean of the reciprocals of the individual observations. What we have calculated, this is basically its statement form. Like arithmetic mean and geometric mean, it lends itself to further algebraic treatment. The fourth one is amongst the three means, that is arithmetic mean, geometric mean, and harmonic mean. Arithmetic mean is the biggest, then comes the geometric mean, and then comes the harmonic mean. You have seen right now that it was easier to calculate arithmetic mean. A little difficult was geometric mean, and similarly there was some level of difficulty in harmonic mean also. Mathematically, if we calculate all these three values for a particular problem, you will see that arithmetic mean is greater than geometric mean, and geometric mean is greater than harmonic mean. For the rates and the ratios involving speed, time, and distance, harmonic mean is used to find out the average speed. For the rates and ratios involving price and quantity, both amount of money spent and the units per rupee are given. Harmonic mean is used. What are its limitations? It is difficult to compute and to understand because we are assuming number one. Number two, calculation becomes too cumbersome. It cannot be computed when one or more items are zero. Then comes the most interesting part of this statistics is median. Normally, learners make error while solving this problem. So listen to me what I'm telling you right now. Median is also a measure of central tendency. Unlike arithmetic mean, This median is based on the position of the observations in a series arranged in an ascending order or descending order. Therefore, it is called a positional average. It has nothing to do with the magnitude of the observations, as in the case of arithmetic. Simply, median refers to the middlemost value of the variable when they are arranged in an order of magnitude. The position of the median in a series is such that an equal number of items are on the either side of it. Median of a given series is the value of the variable that divides the series into two equal parts. It is the most certain point of a series where half of the items lie above this value and the remaining half below this value. Median is denoted by M subscript D. Now, how to calculate median? Median can be computed for both ungrouped and grouped data, but the methods are different. If we talk about ungrouped data, here, first of all, the uh, data is arranged in the ascending order or descending order. It is up to your choice. Then we have to calculate n plus 1 divided by 2th term item, where n is the total number of items. If n is odd, what change will be there? If n is odd, simply do n plus 1 by 2th item. When the number of observation is n, is an even number, so we apply n plus 1 divided by 2, which will involve a fraction. In such case, the median is taken as arithmetic mean of the two variables. Now, for this ungrouped data, the series is 6, 7, 4, 8, 11, 5, 3, 9, 10. The number of observation is 9, which is an odd number. So first of all, first step is to arrange this data in ascending order. After placing up the data in ascending order, we get 3, 4, 5, 6, 7, 8, 9, 10, 11. Here n is 9. Number of observations are odd, so we will be finding out n plus 1th by 1th term. N plus 1. This is 9 plus 1. 9 plus 1 is 10. 10 divided by 2 is 5. That means we will be talking about the fifth term. Going back to the problem, we can see that your fifth term is 7. That means the median for this particular problem is 7. For ungrouped data, here the number of observations are even. Now what different we have to do? If the number of items are even, so we have to calculate the mean of n by 2th term and n by 2th plus 1th term divided by 2. Simply here n is 8. 8 plus 1, 9. 9 divided by 2 is 4.5. That means 4.5th term. We will put this observation in ascending order. This will be 3, 8, 11, 16, 20, 32, 36, 41. We have to find out the median. So here it will be Your fourth term is 16 and your fifth term is 20. That means the median will be sum of 16 plus 20 divided by 2. 16 plus 20 is 36. 36 divided by 2 is 80. Or rather, we can say that the median for this above data is 80. Now for group data. As you know, when the data is in the form of frequency distribution, it can be either in the form of discrete series or continuous series. The method of computing median is different for these two types of frequency distribution. First of all, we will take the example of discrete series. In this case, the following steps have to be followed for calculating median. Arrange the number of observations either in ascending order or in descending order, along with their respective observations, that is, their frequencies. Secondly, convert the frequency into cumulative frequency. Third one, apply the formula MD is equal to n plus 1 by 2th term item. And then we have to calculate this value of n plus 1 by 2th item in the cumulative frequency and determine the value of the value variable corresponding to that cumulative frequency. And we can find out the median. Now the thing is that how it has to be done. Whatever has been discussed right now will be made, made you available in this problem. We have to calculate median. Problem is given to you, marks, number of students. As it was discussed that this data has to be rearranged because in the form of either ascending order or in descending order. We will be converting this data into ascending order. Ascending order means assigning the lowest value of marks in the first column. Respectively, their frequencies will be also simultaneously positioned. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Respectively, their frequencies are placed. Now, how to move further? We have to calculate cumulative frequency. Again, be careful what I'm telling you. This is something normally learners make mistake while calculating cumulative frequency. Straight away see to this. Write 20 in front of this. Add 20 to 43. This comes out to be 63. 63 plus 75, 138. 138 plus 76, 214. 214 plus 72, 286. 286 plus 45, 331. 331 plus 39, 370. 370 plus 9, 379. 379 plus 8, 387. 387 plus 6, 393. Now how to check it? Sum all these terms. You will get 393. That means your n is 393. We have to find out 393 plus 1 by 2th term, which comes out to be 197. Now, we have to find out 197, a number nearer to 197 in this cumulative frequency column, which is this 214. That means we can say that our median marks are 20. Is that clear? Am I audible to you? Can you hear me?
All right, one. Yeah, I can hear you. So
You are understanding it, what I'm telling you. Whatever I'm discussing it, you can grab it.
yeah, I can grab it, sir. Sorry, I'm with.
So that's my basic concern is to make, I should be in a position to understand that you are listening it very carefully because this is the important part of statistics and it will be used throughout your life. Now, for continuous series, a formula changes slightly. MD is equal to L plus N by 2 minus C upon F into I. Now the question arises, what does this all values mean? L is the lower limit of the median class. C is the cumulative frequency of a class preceding the median class. F is the simple frequency of the median class. I is the class interval of the median class. And n by 2 is half of the number of observations. So first of all, write this formula. Then I will tell you how all these values are calculated. Now the problem is given to us in this form. We have to calculate median income. You can see that this is a continuous data. That means it consists of frequency as well as monthly income, and it is in the form of lower and the upper values. Straight away for median, whenever we have to calculate median, we have to calculate the cumulative frequency. Now see to it, I'm just repeating again how this cumulative frequency is calculated. This data is given to you. Straight away write 50 in front of this 50. Add this 500 to this 50. This will become 550. Then add this triple five to 550. This will become 1105. 1105 plus 100, 1205. 1205 plus 3, 1208. 1208 plus 2, 1210. When you are going to add these,
Excuse me, sir.
yeah,
I can't see the window. The what? The presentation. So
yeah,
can you show us the presentation? Yeah, itself.
okay. Sorry, I forgot it.
Yeah, that is okay.
And now it's okay. Sorry, I
Yes.
forgot. But
Yeah, that's okay.
I'm concentrating on the content because I know this is somewhat difficult to understand. So I'm just repeating again how to calculate cumulative frequency. These two columns are given to you. This has to be calculated by you. Now, straight away write 50 in front of this 50. Add this 500 to this 50. This comes out to be 550. 550 plus triple five. This comes out to be 1105. 1105 plus 100. This comes out to be 1205. 1205 plus 3, 1208. 1208 plus 2, 1210. To see whether you have calculated it correctly, add all these values. You will get this 1210. Okay? Now, how to use the formula? We have 1210. So first of all, we have to calculate n by 2. That comes out to be 605 term. Now move to this column. Find out a number greater than 605, which is 1105. That means its median class will be this 200 to 300. L will be 200. Now refer to this part. I'm telling you all the values over here which are to be used in this formula. L is 200. Your cumulative frequency of the preceding class is 550. Your frequency of the median class is 555. Your I, that is the difference between these two, is 100, and your N is 1210. Going back to this formula, L is 200 plus 605 minus 550 divided by triple five into 100. After calculating, you will get 209.91 as the median. Have a look on the slide. Try to understand how this is used, how the formula is used. The basic formula is this one. Because in analysis, you all are learners of BCom, so no, you will be going for MCom, then for the research. All these things will be used again and again. Nothing is going to change. Its application will change. To evaluate it, we have to be very careful in our formulas. Is that clear to you? Have you understood the concept of how to calculate median for group data?
I have a question on this one.
Yes. Yeah, yeah.
The 605. Where are we getting the 605?
Refer to the first line. The formula is n by 2. N by n is 1210 divided by 2.
Okay, okay.
First line, that is n by 2.
All right. I
But
get it.
that n by 2th value will decide your median class. I said find out a number greater than 605 in the cumulative frequency column. So is the
Mm-hmm.
number greater than 605 is this one. So that is why this is the median class. This L is
Mm-hmm.
200, this one. Your F is this 555. Your C is this 550. I is the difference between these two values, and and that's it. This is what is required.
All right, I get it.
Now, what are the properties of median? An important property of median is that the sum of the absolute deviations, ignoring the sign, from the median is minimum. The same thing was informed to you in was discussed while we were doing for the mean. That summation is minimum from the deviations. This property entails the use of median in various practical situations. It is not affected by the extreme values. It is of course affected by the numbers of items because we will be doing n by 2. For an open-ended distribution, median is the more suitable average. For example, since the income distribution is an open-ended distribution, median income would be more representative figure. And for the qualitative information, median is probably the only suitable measure of central tendency. The median can also be located graphically. It is easy to compute, the lucid to understand. In some cases, it is obtained even by an inspection. Depending upon the problem and our experience to solve it, we can do that. Now, what are the merits? For an open-ended distribution, such as income distribution, the median gives a more representative value. For dealing the quantitative phenomena, median is the most suitable average. And since median is not distorted by the extreme values, in some cases it is preferred over mean as the latter is likely to be distorted by the extreme values. Now again, it has some limitations. Median is not capable of algebraic treatment. That means we cannot have a combined median of two or more groups unless all the items of the groups are known. It is described sometimes as an intensive measure as it is not based on all the items of the series. It is affected more by sampling fluctuations than the value of the mean. Then comes your partition value. Partition, as you know that, as I told, that median splits the series into two equal parts. As the median splits the series into two equal parts. That is why it is also known as positional average. In fact, there are some positional measures that partitions the series into still more numbers of equal parts, say 4, 10, or 100 parts. Such measures are generally known as partition values. There are three partition values. First one is quartiles, second one is decile, and the third one is percentile. So depending upon the name, it is easier to understand. Quartile means dividing it into four equal parts. That means Q1, Q2, Q3. First one, Q1, is the lower quartile or the first quartile. Q2 is the mean and median, and the Q3 is the upper quartile. Normally, what does this mean? First quartile, which is also known as lower quartile, is the value of the variate below which there are 25% of the observation. Yes, please. What is your query? Mr. Ahmed, what is your query?
Sorry.
Somebody has raised a hand. I'm just asking what is the query.
Sorry, I can't get it right. Can we come again on the question?
Yeah. What is the question?
I think I should use the headset. I can hear you clearly.
Okay. As I told you, this I'm talking right now about quartiles. Quartile is distribution of the data in four equal parts. Division is done by Q1, Q2, and Q3. Q1 is the lower quartile, which shows the value of a variate below which there are 25% of the observations and above which there are 75% of the remaining observations. Q2, Q2 is the second quartile which divides the distribution into two equal parts. That means 50% on one side and remaining 50% on the other side. That is the median. Remember, Q2 is the median. Q3 is the third quartile or the upper quartile, in which 75% of the observations are above and remaining
Apa?
are below 25%.
Gumagana?
We can, we
Hmm.
can see that Q1 is less than Q2 is less than Q3.
Ano
Now
gulugan?
there are, please mute yourself.
Listo po.
Now how to compute how this
Yung class
computation
sigaya.
of the quartiles is the
Hmm.
what this series or the
Ano
individual
naman?
values are known. When the data is expressed
Ay, sa na
in less than cumulative frequency, that is assigned in the ascending order.
Awan pa. Hadar mi zami ron.
Q1 is the size of n plus 1 by 4. Q2 is the size of twice n plus 1 by 4 item. And Q3 is twice of n plus 1 by 4th item. Now for continuous series. If we have a continuous data with us, then you can see that there is a relation visible to you in your screen. That is Q1 equal to L plus J times N by 4 minus C upon F into I. If you just go back, this formula is somewhat similar to the formula what you use to calculate median. In median, you use the relation n by 2. Here, we will be using n by 4 into j. If we have to calculate q1, j will be replaced by 1. If we have to calculate q2, j will be replaced by 2. And if you have to calculate q3, j will be replaced by 3. Rest, everything will remain the same. Now we come to decile. Decile means dividing the data or distributing the data in 10 equal parts. That means we will be starting from D1 and we will be ending with D9. Here, D5 is the median. There in quatrile, Q2 is the median. In decile, D5 is the median. For discrete series, we have to find out the size of j times n plus 1 by 10 item, where j will be equal to will be varying from 1 to 9. And for continuous series, again refer to my median formula. Here dj is equal to size of L plus j times n by 10 minus c upon f into I. Rest j will be taking the value of 1 to 9 Whatever has to be calculated, just write out the value of the decile D1, D2, D3, D4, D5 till D9. Then comes your mode. Simply, in very simple words, we can say that mode of a particular data is that value which occurs maximum time in the data. Mode is also a measure of central tendency. It is the value of the variate which is repeated most often in the dataset. The genesis of the word mode lies in the French word le mode, which means fashion. Mode is therefore considered to be the most common or most fashionable value. Mode is often considered to be that value of the variable which occurs most frequently. But it is not exactly true for every frequency distribution. Rather, it is that value of the volatile around which the other items tends to concentrate more heavily. It shows the center of concentration of the frequency and in and around a given value. It is not the center of gravity like mean. It is a positional measure similar to median. It is denoted by m naught. Median is denoted by md. Your mean is denoted by x bar. How to compute mode? Again, group data and ungrouped data. So first of all, we will start with ungrouped data. For ungrouped data, the mode is found out simply by inspection. What we will do? The value that occurs most frequently in the given distribution is taken at mode. Now you can see here there are 10 boys whose ages are given to us. Now we have to calculate the mode. See the most occurring number. Here you can see that 6 is occurring 3 times. That means the mode age is 6 years. Now the data comes into this group data for continuous series. This is somewhat tedious. Normally, since it is a part of the curriculum, we have to be aware of it, how it is calculated. For continuous series, you have to calculate m naught equal to L plus delta 1 upon delta 1 plus delta 2 into I. I will tell you what this delta is. Delta 1 is F1 minus F naught. Delta 2 is F1 minus F2. And delta, the two deltas are to be calculated. And L is the lower limit of the model class. Now the question arises, how we will find this L and how we will find this FO and how we will find this F1. So since I said this mode is done by observation or inspection. Right now, you just refer to the relation. I will tell you everything with the next problem what we are going to solve. Here the formula is minimized as m naught equal to L plus F1 minus F naught upon 2 times of F1 minus F naught minus F2 into I. Just write down the formula, then I will show you how it is calculated. The last one is the formula which is applied everywhere. Now see to it. The problem is to calculate the mode of the this group data. After the inspection, in the frequency column, you can see that 8 is the maximum occurring number. We will mark this 8 as FM as you can see over in the problem. Above FM will be Fm minus 1 and below Fm will be Fm plus 1. Now the question arises how to get this LMO. LMO will be 160. Okay, your I will be the this difference between these values. This is 10. You have found out the value of LMO. You have found out the value of FM. You have now you can see the value of Fm minus 1, Fm plus 1. Write all these values in this relation, which will be somewhat like this. After solving, you will get the value as 168. That means we can say that your mode for this particular problem is 168. Is this clear or I should repeat it once again?
No, it's clear. It is loud and clear.
Now it is okay.
Yeah, it is
That's good.
okay.
Now what are the merits and limitations of the mode? In certain situation, mode is the only suitable average. That is the model size of the garments, model size of the shoes. It is very profitably used in market research. In the case of skewed distribution, mode is the indicator of the point of heaviest concentration. And the limitation, as you can see, that tedious algebraic calculations are done. This mode is not capable of further algebraic treatment. It is not based on all the items of the data because we are just picking up or calculating it around the most occurring event. And the value of the mode is affected significantly by the size of the class intervals. Now, remember, there is an empirical relationship between mean, mode, and median. That is, mode is equal to 3 times of median minus 2 times of mean. That means if we have the value of median and mean, so straight away we can calculate mode. By the relation, mode is equal to 3 times of median minus 2 times of mean. This is known as empirical relationship between mean, mode, and median. Now the question is, since we are talking about statistics, how to choose a suitable average? We have discussed various averages, mean, symmetric mean, median, partition value, mode, etc. And have studied merits, demerits, and specific uses of each of the averages separately. Now we should know how to make choice of a suitable average for a given purpose. Examining from the point of view of essential qualities of a good measure of central tendency, arithmetic qualities. Given the situation, however, the choice of a suitable average possesses a problem. If the choice is not proper, the conclusion will not be much dependable. With an improper choice of an average, the comparative scene that merges will be far away from the reality. While making the choice of an average, You should keep in mind the following aspects. Number one, the purpose of the study. Number two, nature and the form of the data set. Number three, amenability to further algebraic treatment. Number fourth, qualitative phenomena. And number five is the special purpose. Though the above considerations act as a guiding principle in making a choice of a suitable average, in many cases it is arbitrary. If the is required to prove the hypothesis, it is tempting to use the measure which gives the higher value. Since we can select the measure of central tendency to sit out fancy, there is a possibility of selecting the average which produces the result we want. Now we will be moving to unit 14. That is, I'm not going to start it today. I'm just giving you the brief introduction of it. Because here, what we have understood in unit 13, its application will be there. How this mode, median, deviation, all are these applied to do the analysis work. That is dispersion. Now the question is what do we understand by dispersion? The degree to which numerical data tends to spread about the average value is called the variation of,
Excuse me, sir.
yeah.
The
Presentation window has disappeared.
No, I'm not showing you the presentation
Ah, all right, all right,
because this is the conversation. This is the basic concept of it. Normally
all
in
right,
mathematics, the presentation is placed to show you the calculation purpose.
all right.
This is a basic introduction to the subject. I told you this is the introduction to dispersion. That is, I'm talking about unit 14. That is measure of dispersion. Now the question is, what is dispersion is? Then what is the concept of dispersion? The degree to which numerical data tends to spread about an average value is called the variation or dispersion of the data. The measurement of scatterness of the mass of figures in a series about an average is called measure of variation or dispersion. Different people have different thinking about the same thing. Dispersion or spread is the degree of scatter or variation of variables about a central value. Rather, we can say that how much things are being deviated from the central position or the central value. Dispersion is used to denote the degree of heterogeneity in the data. It is an important characteristic indicating the extent to which observations vary among themselves. A measure of dispersion describes the spread or scattering of individual values around the central value. You have seen that I use this deviation or dispersion while calculating mean. A calculated D was there, that is the deviation from the assumed arithmetic mean. That assumed arithmetic mean was that arithmetic mean was assumed by us. What is the significance? Why? But the thing is that why do we study this dispersion? Measure of dispersions are calculated to serve the following purposes. Number one, measuring variability determines the reliability of an average by pointing out to what extent average is representative of the entire data. Measure of dispersion enables comparison of two or more distributions with regard to their variability. And number three, another purpose of measuring variability is to determine the nature and cause of the variation in order to control the variation itself. Now, further to it, where it will be used. Measuring variability facilitates the use of other statistical measures like correlation, regression, statistical inferences, etc. Now, see, the application of dispersion is in correlation, regression, and statistical inferences. What are the properties of good measure of dispersion? A measure of dispersion is the average of the deviation of items from its mean. That is, it is an average of second order. Hence, it should also possess all the qualities of a good measure of an average. According to Yule and Kendall, the qualities of a good measure of the dispersions are: number one, statistical measures are used even by laymen, so complicated definitions and calculations are not desirable. It should be simple to understand and easy to calculate. Number two, it should be rigidly defined. For the same data, all the methods should produce the same answer. You have seen it while I was discussing about the mean. I calculated the mean of a particular problem by two methods and we got the same answer. Different methods of computation leading to different answers are not proper. Number three, it should be based on all the items. When it is based on the all the items, it will produce a more representative value. Thus, good measure of dispersion should be based on the entire data. Fourth one, it should be amenable to further arithmetic treatment. This means combining groups, calculation of missing values, adjustment for wrong entries, etc., which are possible without the knowledge of actual values of all items. This application, what I'm telling, I use the word missing values, calculation of missing values, adjustment of wrong entries. This can be done with the help of when we are having two information, that is the mean and the number of observations. We can use the missing value, we can calculate the missing value, or we can remodify the summation of observations. Now the thing is that what are the measures of dispersion? The following measures of absolute dispersion are in common use. First one is it is based on selected items of the data. First one is range. Second one is interquartile range. Third one is quartile deviation. When it is based on all items of the data, we have to calculate mean deviation, standard deviation, or root mean square deviation, or graphical method, which is Lorentz curve. The relative measure of dispersion corresponding to the measures of absolute dispersion are: if we talk about range, we can calculate coefficient of range. If we are calculating or we are talking about quartile deviation, then we can calculate coefficient of quartile deviation. When we are talking about mean deviation, we have to calculate coefficient of mean deviation. And whenever we are calculating standard deviation or we are talking about standard deviation of the data, we can calculate coefficient of standard deviation. Coefficient of standard deviation, when expressed in percentage, is also called the coefficient of variation. With this, I will be stopping over here because moving further to it, it will be transforming this, our conversation will be transforming into your arithmetic part and analysis part and calculation part. So I want that it should be started in the next session when we are going to meet. Any questions from
sir.
anyone? Because I have talked. We have a discussion regarding mean, mode, median,
Mm,
deviation, quartile deviation, decile, percentile. So as we will be moving further, we will be using these terms again and again. So I want that you should be very much conversant with all these things because further, whatever in the later part of our course, we have to apply these terms, apply these formulas to get the conclusion. So I want that you should all be familiar with the terminology and the formulas. Because it will be easier for me as well as for you to understand what I'm telling you or what I'm discussing with you. Any question from anyone?
no question, sir.
Any problem with any part of the discussion?
No question, sir.
If you have any problem, because this is mathematics, statistics, if you have any problem, just let me know. I will be trying my level best to assist you in getting the desired result.
Sorry, sir, but I think where I need help from, it's about the functions.
Function.
Yes, I'm not clear about the functions. I've been having difficulties to understand the functions.
Okay, so what is your query now? What do you
I would, I would kindly ask if maybe in the next session you could at least
yeah,
leave
yeah,
30 minutes for us to go through some questions in functions.
correct.
Yes.
That will be the right method. Because again, I will be telling you the frequent this theory part, but the thing is that I should be in a position to understand what exactly your problem is all about.
Right, sir. I
You
will
just
explain in the next
yeah, yeah,
session.
yeah. Sure, sure, sure.
Sir.
Yeah. So shall we conclude today's session?
Yeah, we can close.
Yes, we can, sir.
Yeah, okay.
All right.
Thank you.
Bye, sir. Thank you.
Yeah, good day.
Bye
Thank
bye.
you so much.
Yeah.
Thank you.